Let's talk about simplifying radicals. To start with, let's look at some very basic examples of radicals. Our most basic example is the square root of x. We see that one very often. The other basic example might be the cube root of x. We also have the fourth root of x. To simplify radicals, we use inverse operations like we do often in math to get rid of things. So simplifying a radical usually means there's something underneath the radical sign that can come out evenly. So for instance, if you have something squared underneath the square root, it would come out evenly. If you have something cubed that's underneath a cube root symbol, it would come out evenly. So when we want to simplify, we want to look for those things that would have a square or a cube underneath those symbols so that we could take them out. So some vocabulary are the radical would be the little house, we call it. And what's underneath the radical is called the radicand. Some simple examples down here at the bottom. I've put the square root of 4, so let's look at that example. The square root of 4 is equivalent to the square root of 2 times 2. And 2 times 2 is equivalent to 2 squared. So if we think about it, the square root of 4 will come out evenly as 2 for more than one reason. There's 2 2's, so we could take one out. We can think of it that way. Or there's 2 squared. So the square root of something squared, those are inverse operations, so they cancel each other out and you're just left with 2. The square root of 9 works similarly because you have 3 times 3, which is equivalent to 9. 3 times 3 is the same thing as 3 squared. So if you have the square root of something squared, they're inverse operations. So they cancel each other out, and you would just have the 3. You would have no more radical sign after that. For the same reason, we could look at the cube root of 8. The cube root of 8 is equivalent to the cube root of 2 times 2 times 2, because those would give me 8. 2 times 2 times 2 is equivalent to 2 cubed. And so we could say the cube root of 2 cubed, they would cancel each other out and we just have 2. And also the cube root of 27 would work the same way. The cube root of 27 is equivalent to the cube root of 3 times 3 times 3, which would be equivalent to the cube root of 3 cubed. So we could say that would just come out evenly as 3 because the cube and the cube root are opposite or inverse operations. They cancel each other out. So when we're simplifying radicals, we're going to be looking for things that we have 2 of if it's a square root, and we have 3 of if it's a cube root. If it was a 4th root, you look for something that you have 4 of. If it's a 5th root, you look for something that you have 5 of, and so on. But usually these are the most popular. So let's check out some examples of this. So for square roots, we're going to focus on those first. We factor out all of our numbers into prime numbers and write out the variables so you can see everything you have underneath the radical, and you'll easily be able to see what you can take out and what's left over. So then we're going to take out whatever we have 2 of or a pair of. So if I factor out 8, let me get a marker that works. We could say 8 comes from 2 times 4. 4 comes from 2 times 2. Now when I'm factoring numbers, I try to cancel what I've rewritten. You see how 4 I've rewritten as 2 times 2? So mark out the 4 because really you've already replaced that with 2 times 2, and that way you don't get confused as to what's still there. So now we can see we have a pair of 2's. So we could take out 1 2 for that pair of 2's. So we'll have 2 on the outside, and left over, we have this 2 that we haven't circled. So that would be our simplified radical. The square root of 8 is equivalent to this to 2 square root 2. Excuse me. Let's look at example 2. I have a 4 out front and the square root of 24. So I'm going to break down the 24, and whatever I take out will multiply with that 4 that's already out front. But in the meantime, I just leave that 4 there. So let's say 24 comes from 4 times 6. 4 comes from 2 times 2. And 6 comes from 2 times 3. Those are all my prime numbers that would multiply back together to give me 24. I mark out the ones I've already factored out. or rewritten, and I look for what do I have 2 of. So I could circle this pair of 2's right here. So I'm going to take 2 times 4, and I will have the square root of 2 times 3 left over. So that cleans up to look like 8 on the outside and 6 on the inside. So 4 square root 24 is now simplified to be 8 square root 6. Let's look at example 3. So for example 3, I have the square root of 32 x cubed y to the 4th power. So this is the first one with some variables. So we're going to write them out, and that way it's easy to circle what we're going to take out and easy to see what's going to be left over. So 32 comes from 8 times 4. 8 comes from 2 times 4. 4 comes from 2 times 2. And this 4 also comes from 2 times 2. Now see how you have all those numbers floating around right there. So it's good to mark out the ones you've rewritten so you don't think those numbers are still there. So I rewrote 8, I rewrote 4, and I rewrote 4. So get those out of your way so you don't think you still have those numbers there. Now I'm going to write out all my x's. So I have 3, I have 4 y's. That way I can see everything possible to take out. So I have a pair of 2's, I have another pair of 2's, a pair of x's, and 2 pairs of y's. So when you have a lot going on, you want to take your time and make sure you've gathered up everything you're going to take out, and then you can also see what's left over. So I have 2 times 2 would be 4, x, and 2 y's, so we represent that with our square. And I have the square root of 2 times x left over. So that would be my simplified radical. Let's check out example 4. So this time I have a -3 out front. So this one's going to work like example 2 did. Whatever I take out is going to multiply with that -3. But in the meantime, I just leave it there. So we break down 20 into 4 times 5. 4 will become 2 times 2. So mark out 4 since now it's 2 times 2. We have 3 x's. We have 5 y's. So we can see all of what we have. So we're still dealing with square roots, so we want to circle things we have 2 of. So we have 2 2's, 2 x's, and 2 pairs of y's. So then you check and make sure you've circled everything. And we have 2 times -3, which will become -6. We have x and 2 y's, so we square it again. And the square root of 5xy would be left over. So that's our simplified radical for -3 square root of 20x cubed y to the 5th. Now, let's look at some cube root examples. So with cube roots, the directions are very similar, except for on these, you're going to take out what you have 3 of. So the root number, like on those, they were square roots, so we took out 2. Things we have pairs of. So for cube roots, you want to take out things you have 3 of. So if you don't have 3 of something, you can't take anything out. So we want to break down 16 for our first example, the cube root of 16. So we have 8 times 2. Adjust my board so it doesn't fall on me. And then I have 8 comes from 4 times 2. 4 comes from 2 times 2. So mark out what you have rewritten. And we're not circling pairs this time. You got to be careful with that. We have a group of 3 2's. So we could take out 2, but then the cube root of 2 is left over. So it's easy to make the mistake and just write the radical, but that would be a square root. You want to make sure you put the cube root if that's what you were given. If anything is left over, it has to go under that sign. But that would be it. The cube root of 16 is equivalent to 2 cube root 2. Let's check out example 2. We have the cube root of 8, x to the 4th, y cubed. So we break down our 8 into 4 times 2 and 2 times 2 and mark out what you rewrite. I have 4 x's and 3 y's. So we're circling groups of 3. So I have 3 2's, 3 x's and 3 y's. So almost everything came out evenly on this one. And sometimes you will be able to take out everything. So I have 2xy will come out evenly. Remember to leave the cube root of what's left over, which is just x. And that's it. Let's check out example 3. I have a 3 now out front, so just like on our square root problems, we're going to take out what we can and then multiply that by that 3. But in the meantime, it just stays there. So we have 54 comes from 27 times 2. 27 comes from 9 times 3. And 9 comes from 3 times 3. So mark out the numbers that you've rewritten. We can write out all of our letters. And we can circle things we have 3 of. So we have 3 3's and 3 y's. But we can't forget the 3 that's out front. So we have 3 times the 3 that's already out front would be 9. We have 1 y we're going to take out. And then we have the cube root of 2x y squared left over. And that'll be the answer for that one. Let's check out example 4. Now we have a negative out front. In math, remember, if you don't see a number right there and there's just this negative, it's like a -1. So we're going to multiply what we take out on example 4 times -1, but meanwhile it just stays there. But don't forget about it. Like break down 24. We could say it's 8 times 3. 8 comes from 2 times 4, and 4 comes from 2 times 2. So you go back through and mark out what you've rewritten. We have m to the 3rd and n to the 7th, if that's hard for you to see. So I'm going to write them all out. And we can circle groups of 3. So we have 3 2's, one group of n, another group of n, and a group of m's. So we're going to take out 2, but times -1 would be -2, 2 n's, and an m. So usually we put these in alphabetical order. So let's put m, n squared, and then the cube root of 3n is left behind. So the things to be careful about are writing the correct root with what's left over. That's a mistake that's commonly made. So if you put just the square root right here, you've gotten all that work done and then you wrote the wrong answer. So just be careful with that part.